This is Komaba, Meguro-ku, Tokyo. Komaba is home to one of the largest university-affiliated institutes in Japan, an institute that mainly carries out research in engineering fields. It is the Institute of Industrial Science of the University of Tokyo. Our institute consists of more than 110 laboratories. More than 1,000 researchers are gathered here from around Japan and all over the world to conduct a wide range of fundamental and applied research. Our research outputs contribute to a brighter future for humankind and our global environment. The campus is located in an attractive green environment which is open to the public. It provides a relaxing and peaceful atmosphere. At the Kashiwa campus, practical experiments and simulations are conducted, making use of the large-scale facilities and vast grounds. These activities are led by LEAP, which stands for Large-Scale Experiment and Advanced Analysis Platform. In addition, at the Kashiwa 2 campus, the Design-Led X platform has been established with a linkage to the Komaba campus. Designers and researchers collaborate closely to develop projects that bring the future to life. Since its establishment in 1949, the IIS of the University of Tokyo has deepened knowledge through fundamental research related to engineering. It has also contributed to industrial innovations through applied research. The areas embraced by the Institute of Industrial Science of the University of Tokyo range from microscopic worlds at the quantum level to the human-scale world we inhabit, and to worlds beyond. From the cities and regions that form the foundations of society, its activities extend to the macro scale, occupied by the Earth and space. In short, the Institute is involved in almost every aspect of engineering. Each laboratory belongs to one of 5 departments. Each has multiple research themes. Within a department, multiple laboratories launch joint projects. To achieve common goals, laboratories also establish research centers to collaborate across departments. Researchers communicate freely across divisions and research fields, stimulate each other, and collaborate to increase their practical engineering abilities.
Tokyo 大学生産技術研究所は工学に関わる諸課題および価値創生を広く視野に入れ、先導的学術研究と社会・産業的課題に関する総合的研究を中核とする研究教育を推進し、その活動成果を社会・産業に還元する。それを所の設置目的にしています。最先端のその先にあるもしかする未来に向けて政権は動き続けます。
The areas covered by the Department of Fundamental Engineering include the experimental and theoretical physics of soft and nanostructured materials, mechanics, and earthquake engineering. Here, we've successfully developed technologies for the mass production and in-flight handling of microliquid droplets. These are now applied in the fabrication of hybrid microcapsules based on collision processes of multi-particles. We produce reinforced plastic-based containers wrapped in carbon fiber for ultra-high-pressure hydrogen gas used by fuel cell vehicles. Based on the results of extensive experiments, they are designed with the strength to resist explosions. Recent development of mechanical exfoliation and van der Waals assembly of atomic layers opened up new possibilities in materials science and technology. We're developing novel electronic devices by stacking various atomic layers, such as graphene and 2D materials, in designed sequences. With the aim of achieving safe and comfortable buildings and cities, we conduct research to propose solutions for improving their performance and resilience. The Department of Mechanical and Biofunctional Systems studies mechanical, precision, and ocean engineering. It conducts research into innovative machines, devices, and systems. Three-dimensional printing technology can produce functional shapes quickly and precisely. It can be used with multiple materials including plastics, rubber, and metals. Injection molding technology allows us to freely manufacture new parts from various plastics, rubber, and metal composites. Human life is closely linked to the oceans, which cover 70% of the Earth's surface. To ensure the sustainable use of marine resources, we explore the essence of the ocean's functions and measure and evaluate potential and risks through marine observations. Applied engineering brings together multiple fields, including sensing, platforms, and simulations. The Department of Informatics and Electronics engages in three areas of research: information and computer sciences and nanoelectronics, photonics and very large-scale integration, and energy, motion control, and micromachines. We develop remote control robot technologies that use virtual reality. These will meet needs in various areas in the future. We also digitally archive important cultural properties by integrating robot and sensor technologies. Semiconductors underpin today's advanced information society, from smartphones and AI to transportation and power grids. We will enhance people's lives by pursuing a wide range of silicon technologies for innovative large-scale IC and power electronics, while actively collaborating with industry. Life is a complex and self-organized system. To understand its principles, we develop algorithms to track dividing cells in developing embryos and figure out the rules and patterns in the process of development. The Department of Materials and Environmental Science conducts extensive research ranging from fundamental studies to advanced material development. We aim to overcome diseases and understand brain development by combining analysis on protein synthesis regulations in neurons with molecular and genetic approaches, and neural tissue engineering using microdevices. Integration of materials and energy research is essential to realize a sustainable society. By developing new materials for carbon neutrality and new technologies for clean energy production, we will promote activities that encompass the entire energy issue, from energy supply to final use and recycling. Through collaborations among several laboratories in various fields, we've developed a radioactive cesium decontamination cloth based on Prussian blue. Because it is easy to produce and handle, this cloth is used for removing radioactive cesium ions. The Department of Human and Social Systems conducts studies on architecture, infrastructure facilities, and urban, regional, and global environments, which are social areas where human beings interact. To solve global issues related to water, we simulate global hydrologic cycles, monitoring climate changes, and investigate the balance between water demands and supplies. We aim to achieve a secure and sustainable society by managing flood risks and water resources. We also conduct research to develop innovative structural systems. Tensegrity skeleton, one of the most advanced lightweight structures, has been well studied and constructed as a full-scale practical skeleton for the first time in the world to demonstrate our achievements. In order to build capacity for minimizing the damages caused by disasters and for protecting human lives, the Disaster Management Training Center provides training for knowledge and skills for management of disaster response based on the theory and technology of disaster preparedness. The Institute of Industrial Science has research centers for strategically important project research, as well as laboratories specializing in different fields that collaborate flexibly. Using the latest supercomputers, we perform highly accurate simulations on the effects of the fluid dynamics of water or air on vehicles, ships, and aircraft wings. Here, we are exploring ultra-small light emitters that move freely, guided by tiny ultrasound forces. Gesture-controlled free-space optical networks. And drug-loaded microneedles, less than 50 micrometers in diameter, that allow absorption directly through the skin. At the forefront of advanced science. We will open up engineering by creating unprecedented contact with society and the public, using the methods of science communication. We extract latent issues through surveys of groups that are sensitive to specific issues, and through research in regions where social issues are likely to become apparent. We develop a general spatial description platform overlaying real-time positions and gestures in remote locations, as if they were in the same space. Our aim is to technically lead the world in the field of spatial description, enabling seamless collaboration between virtual and physical spaces among various industrial domains. Frequent market instability impacts social, business, and government initiatives. Our center analyzes time series data and employs advanced math to detect signs of high market volatility. Our aim is to collaborate with the Financial Services Agency to effectively control financial instability. We explore interfaces between engineering and biotechnology. Our research involves culturing cardiomyocytes and skeletal muscle cells on thin-film transistor devices and developing new chemical sensor devices by incorporating molecular recognition materials into organic thin-film transistors. We utilize blockchain to enhance the reliability of overseas coffee plantations and sheep farm supply chains. This will lead to better product quality, improved work environments, and a more advanced distribution system. We will research into this platform to enhance its reliability further. We are researching efficient cultivation methods using remote sensing technology with drones and self-propelled robots toward domestic production of profitable pecan nuts. Also using robotics and image analysis technology to spray chemicals in broccoli cultivation. And we developed a floating fish cage and succeeded in coho salmon aquaculture, we are practicing food production technology and its return to society. The Institute of Industrial Science contributes to communities through industry collaborations. We return our research outputs to society by working not only with industry, but also with national and local governments. In an era of big data, we promote ITS research to achieve a mobility society, integrating engineering fields such as transport, vehicles, and information technologies, and conduct research in collaboration with academic, public, and private sectors. The automated driving bus pilot deployment project at Kashiwa City is moving towards safe and sustainable mobility. We're engaged in a reconstruction project for the Tohoku area, which was affected by the Great East Japan earthquake. The positions and shapes of architectures are measured using a sensing vehicle equipped with omnidirectional cameras and laser sensors. The Kama House, built on the Komaba campus, is used as a platform to perform research experiments for various companies. As a leader in the engineering field with excellent manufacturing technologies, we aim to create new design-based values by fusing aesthetic senses in areas such as sports. The Office for the Next Generation, ONG, aims to introduce the latest science and technologies into elementary and secondary education by cooperating with industries.
大学院生とか東大の人の講義を受けれたのは貴重な体験だから
車輪のその形状とか傾きとかを体感することができて
裏側とか普段働いている方々の細かいところまで
飛行機への理解が深まってよかったです。
いい経験になったと思います。今後生かしていきたいです。
This institute, where a number of international researchers are enrolled, promotes international collaborative studies and academic exchanges, and has signed many international exchange agreements with various institutions around the world. The Laboratory for Integrated Micromechatronic Systems collaborates in international research with the CNRS in France. The aim is to explore new frontiers in nanotechnology, biomems, and advanced MEMS. The New York office promotes collaborative research with universities and industries in the United States and organizes international symposia. The Institute of Industrial Science of the University of Tokyo, as one of the world's top institutes in the field of engineering, is committed to being a dynamic, intellectual institute that creates practical knowledge together with society.